Alrighty, here's another example of solving a system of equations using Gauss-Jordan elimination. So our goal is to get this matrix to reduced row echelon form, which I don't know if I mentioned in my last video, but reduced row echelon form is unique for matrices, which is different than row echelon form. So also, if you have different answers in row echelon form, that could be completely fine, but the x, y, and z, once you actually solve it out, should be the same. So I just put this system into an augmented matrix, and I'm going to solve this kind of the more traditional way than I did in my last video. So I want to get a 1 in this first position, and for this matrix I'm actually going to do that by switching rows 1 and 2. So in my next matrix I'm just going to write like this guy is now row 2, row 1 got swapped. And then put my new matrix in here. Kind of a quick way to get that leading one up top. Alright, I think everything's set. Really trying to be careful here. Make sure I don't make any silly mistakes. I think you guys should do the same. Okay, so next I want to get all zeros below that first leading one. We only have to worry about row 2. So I'm going to do 4 row 1 plus row 2. I'm going to go ahead and make those changes, and you guys can feel free to pause me or whatever we need to do to keep it going. So we'll have a -1, 4 row 1, -4 plus row 2 will give me a -5. 4 row 1 is 8, plus row 2 gives me a -3 there. All right, so my next step, I want to get this position to be a 0. And I actually want this guy to be a positive 1, but I figure I'll change that at the end with my last steps. It's already a 1, right, just negative, so no big deal for that. So I'm going to come up to the top, and I'm going to do 2 row 2 plus row 3 to get our 2 down there to be a 0. So try to copy this matrix again. A little messier when I have to be zoomed out. All right, so 2 row 2 would give us a -10, plus 4 would be a -9, I'm hoping. And then a -6. 4 times 3 is -12. And what am I doing? 2 times row 2 should give me a -6 plus row 3. I feel like I might have done something off here. Alright, figured it out. Hopefully you guys are yelling at me over the computer, because this guy should be a -6, right? So clean that up. Oh, having some technical difficulties here, because if we do 2 times -5, that's -10, plus 4 is a -6. And then it looks like we get the same thing over here. 2 times -3 plus 0 is -6. So we're looking pretty good so far. We're one step away from row echelon form. I'm just going to get rid of that -1, make it a positive, and divide the last row by a -6 also. So I'm going to have -1, oh, not helpful writing with the highlighter, -1 times row 2, and 1/6 times row 3. Okay, and then we have really only one step left for this matrix to get to reduced row echelon form. We need to clear out all the zeros above our leading ones. And this second column here, we already have a 0, so that guy's good. So we need to get zeros in this last column up top. So we can do this in one step. We're going to use the leading one, again on the bottom. So for that -1 in the first row, third column, I'm going to do row 3 plus row 1. And to clear out the 5, I'll do -5 row 3 plus row 2. Get these all set. So I've got my 1, 0. This guy will become a 0. And then row 3 plus row 1 will give us a 3 up here. -5 row 3, that'll be the 0. -5 plus 3, -2. And 0, 0, 1, 1. So really just, like one extra step for this matrix to get the reduced row echelon form. And this really nicely gives us our solution where x equals 3, y equals -2, and z equals 1. And again, reduced row echelon form is unique for every matrix, so we should be all set.